For the past decade, the traditional auto industry has sold American drivers a comforting compromise and called it innovation. The promise was simple: keep the gasoline engine bolt on a small battery, add just enough electric assistance to satisfy regulators, and present the result as the future. But a compromise powertrain is still a compromise. It carries the weight of two systems, the friction of old mechanical logic, and the same quiet dependence on fuel once the battery buffer disappears. What makes the Neta L dangerous is not that it is another electrified SUV. It is that it points to a more ruthless answer. This machine is built around an extended range electric architecture, where the vehicle is driven by electricity first, and combustion is demoted to support duty. On Neta's global product page, the model is presented with about 200 kilometers of pure electric range and 1,070 kilometers of comprehensive range, while Chinese launch coverage cited domestic variants with up to 310 kilometers CL, TC battery range, and 1,300 kilometers combined range. That is not an upgrade to the old hybrid story. That is a direct threat to it. For years, the American market was conditioned to believe that electrification had to arrive in one of two approved forms. The first was the full battery electric vehicle, which promised silence and instant torque, but came with the political and infrastructural burden of charging access, grid confidence, and winter range anxiety. The second was the legacy plug-in hybrid sold as the respectable middle ground, a little electricity for daily commuting, a gasoline engine for reassurance, and just enough battery capacity to claim modernity without truly abandoning the mechanical worldview that built Detroit, Stuttgart, and Tokyo. That compromise became emotionally attractive because it felt familiar. It did not ask buyers to trust a new architecture. It asked them to decorate the old one. That is the blind spot the Neta L is attacking. An extended range electric vehicle does not simply split the difference between gasoline and battery power. In the series-style logic used by modern EREVs, the electric motor remains the device that actually moves the car, while the engine serves as an onboard generator when needed. That sounds like a small engineering distinction, but it changes the hierarchy of the machine. In a conventional parallel hybrid, or many plug-in hybrids, the engine still retains a direct mechanical role in propulsion. In an EREV, combustion is demoted. Electricity becomes the primary language of motion, and fuel becomes backup infrastructure carried inside the vehicle. That difference matters because the old hybrid bargain was built around preserving legacy hardware, not defeating legacy inefficiency. It allowed manufacturers to keep engines, transmissions, and familiar supplier ecosystems alive, while still talking the language of electrification. From an industrial standpoint, that was convenient. From a consumer standpoint, it often meant paying for two propulsion systems in one vehicle and trusting software to hide the compromise. The Neta L enters that historical moment like a hostile exhibit. Neta's own global positioning frames it as an extended range SUV, not a conventional hybrid, and the vehicle's stated 200 kilometers NEDC pure electric range and 1,070 kilometers comprehensive range are precisely the kind of numbers that make the old plug-in script look defensive rather than visionary. Chinese launch reporting went even further, citing EREV variants with up to 310 kilometers CLTC battery range and 1,300 kilometers combined range. Once numbers like that enter the conversation, the old question changes. The question is no longer whether consumers will tolerate electrification. The question is why they should continue tolerating an architecture designed to protect the past. And that is why this matters far beyond one Chinese SUV. In the United States, truck owners, crossover buyers, and even skeptical EV shoppers have been told for years that the path forward must involve some version of sacrifice. Sacrifice charging time, sacrifice towing confidence, sacrifice winter usability, or sacrifice the familiarity of combustion. The EREV proposition is dangerous because it tries to reorganize those sacrifices rather than simply manage them. It says the engine should not remain the hero. It should become a servant. And once that idea feels normal to mainstream buyers, the legacy industry does not just lose a product category. It loses the logic that justified half its engineering decisions over the last decade. The first pillar is the powertrain hierarchy, and this is where the old plug-in logic starts to look mechanically compromised. In an EREV, the engine is not there to share glory with the electric motor. It is there to serve it. Unlike a conventional PHEV, an EREV uses a series configuration in which the combustion engine acts as a generator and the electric motor drives the wheels. Launch coverage for the Neta L says its EREV system pairs a 1.5-liter 4-cylinder range extender with a battery pack of up to 40.27 kilowatt-hours, delivering up to 310 kilometers of CLTC electric range and up to 1,300 kilometers of combined range in the Chinese market. That matters because it changes what the driver feels and what the machine prioritizes. On a long Texas highway run, the argument is no longer about whether a transmission can juggle engine and motor efficiently. The electric motor does the driving. The generator's job is to stay in the background and feed electrons into the system. That is a different mechanical philosophy from the legacy plug-in formula. And once American buyers understand that difference, a lot of old hybrid engineering begins to look like an expensive way of preserving the past. The second pillar is battery logic, and this is where the Neta L becomes harder to dismiss as just another budget electrified SUV. CATL introduced Shanxing as the first 4C super-fast charging LFP battery, with claims of 400 kilometers added in 10 minutes and a chemistry strategy built around making LFP charge faster and work better in difficult temperatures. The Neta L does not reproduce every headline number from CATL's top Shanxing demonstrations, but it clearly inherits the direction of that ecosystem. Official product material and launch reporting show a large battery for an EREV of this size, with global marketing quoting 200 kilometers, NEDC pure electric range, and Chinese market reporting citing up to 310 kilometers CL TCEV range, plus charging from 30% to 80% in less than 19 minutes at up to 2.6 C. That combination matters more than one glamorous laboratory metric. It means the vehicle is not treating the battery as a token compliance device. It is using a serious battery to let most daily driving happen electrically, then using the range extender as insurance. For an American family in suburban Michigan or outside Denver, that is the dangerous part of the equation. You get a vehicle that behaves like an EV for routine use, but does not force the household to treat every long winter trip like a charging strategy seminar. The third pillar is structural integration, and this is where the battle stops being about chemistry alone and becomes a fight over the vehicle's entire physical architecture. CATL publicly describes its cell-to-chassis approach as integrating battery cells directly with the vehicle body and chassis, reducing complexity and pushing the battery toward a structural role rather than a passive box of modules. Neta and CATL also announced cooperation around CATL's integrated intelligent chassis and CTC technology, which is important because it signals the industrial direction behind vehicles, like the Neta L, even when a consumer-facing brochure emphasizes comfort features more than structural diagrams. That direction matters to American viewers because every redundant enclosure bracket and layer in a battery system costs money, weight, and packaging freedom. A more integrated floor can improve space use, help lower the center of gravity, and support better efficiency from the same energy input. In plain language, this is the moment when the battery stops acting like a fuel tank and starts behaving like part of the skeleton. And once that design logic matures, legacy manufacturers are no longer just losing on cells. They are losing on the architecture that decides how the entire vehicle is built. The fourth pillar is digital architecture, because a modern vehicle no longer loses only through metal and chemistry. It can also lose through latency. Reporting around the Neta L says the cabin uses dual 15.6-inch screens, powered by a Qualcomm Snapdragon 8155 chip. Separate launch coverage also ties the Neta L's smart driving hardware to Horizon Journey Silicon Plus cameras, millimeter wave radar, and ultrasonic sensors. The reason this matters is simple. Once the car becomes a computing platform, responsiveness itself becomes a luxury feature and an engineering weapon. A screen that reacts instantly, a system that can run multi-screen functions smoothly, and an assistance stack that fuses radar and camera data in real time, all change how modern buyers define advanced. For an American consumer used to judging trucks and SUVs by engine size badge heritage or leather quality, this is the uncomfortable transition. The value is migrating from visible hardware to integrated computation. And when that shift accelerates the brands that still treat software as an accessory risk, looking like industrial giants trying to fight a semiconductor war with mechanical pride. When this architecture is translated into American market logic, the comparison becomes uncomfortable very quickly. The gasoline Ford F-15 still advertises up to 13,500 pounds of max available towing. The 2025 Ram 1,500 goes to 11,550 pounds, and the 2026 Silverado EV reaches up to 12,500 pounds, while the F-15 Lightning tops out at 10,000 pounds in certain trims with the Max Trailer Tow package. Those are serious numbers, and they matter because American buyers still judge capability through payload, trailer weight, and long-distance confidence. But that is also exactly where the Neta L becomes dangerous. It is not trying to beat a full-size pickup at maximum tow rating. It is attacking the much larger daily use territory where families want electric smoothness, low running costs, and no dependency on perfect charging infrastructure. In that zone, a vehicle marketed with around 200 kilometers NEDC pure electric range and 1,070 kilometers comprehensive range globally, and reported in China with up to 310 kilometers CLT, CEV range, and 1,300 kilometers combined range starts to look less like an alternative crossover and more like a challenge to the assumptions behind both the PHEV SUV and the mainstream EV. Tesla's Model Y shows the other side of the US benchmark problem. On Tesla's official page, the rear-wheel drive Model Y is listed at 321 miles, EPA estimated range, while the all-wheel drive version is listed at 294 miles with up to 160 miles of range added in 15 minutes under ideal supercharging conditions. That remains a strong benchmark for a mainstream American EV crossover. But it depends on charging behavior, charger access, and route planning discipline. The Neta L attacks from a different angle. It offers a meaningful electric-first driving experience, but it also carries its own fallback power infrastructure inside the vehicle. For an American commuter in California, that means EV-like daily operation, without the same psychological dependence on the charging map. For a household in winter states, it suggests a different kind of resilience, not the purity of a full battery EV, but the strategic flexibility to keep moving when temperature distance or rural access begin to punish idealized EV assumptions. That is why the threat is industrial, not cosmetic. It does not need to beat Tesla at everything. It only needs to persuade enough buyers that the next stage of electrification may not belong exclusively to pure BEVs or legacy plug-in hybrids. The most revealing American benchmark, however, may be Ram's own future strategy. Ram's official electric truck page now describes the all-new Ram 1500 REV as the world's first ever range-extended full-size electric pickup truck, with projected availability in 2026 up to 690 miles of range and up to 14,000 pounds of max towing when using a fully charged battery and a full gas-powered onboard generator. That matters Because it is an admission from inside the US truck establishment that extended range logic may be one of the few realistic ways to electrify American expectations, without asking truck buyers to accept a wholesale downgrade in utility. In other words, the architecture represented by the Neta L is not a foreign oddity. It points toward a direction that even an American truck brand now appears willing to validate. And once that happens, the competitive danger grows beyond one model. It becomes a race over which industrial system can build the most convincing electric-first range-secure vehicle at scale and at cost. This is where the Neta L stops being a product story and becomes a supply chain story. The battery war is no longer just about who can design a better pack. It is about who controls the industrial ladder beneath that pack. Cathodes and ODs refining cell production and the manufacturing equipment that turns chemistry into scale. China accounts for around 80% of lithium-ion battery supply chain production capacity, while LFP is now close to half of the global electric car market, and more than 98% of LFP cathode material and LFP battery cells are produced in China. That means when a vehicle like the Neta L uses electric-first logic and leans into LFP economics, it is not merely choosing a battery chemistry. It is stepping into a supply ecosystem that the West still does not control. That is why tariffs are rising. In 2024, USTR announced Section 301 tariff increases that took electric vehicles from China to 100%. And lithium-ion EV batteries to 25%. Those tariffs tell you two things at once. First, the United States understands that this is an industrial security contest, not a normal consumer goods dispute. Second, tariffs are a defensive wall, not a manufacturing strategy. They can slow market entry, but they do not magically create domestic cathode capacity, domestic anode leadership, or a fully competitive battery cost structure. If the architecture wins and the cost curve keeps falling, protection buys time, but only time. The labor question is just as serious. The UAW has been explicit that the EV transition must be a just transition, and that workers cannot be left behind. At the same time, US EV battery demand in 2024 nearly matched the European Union, while global electric truck battery demand grew more than 75% in that same year. In other words, the American market is already large enough to matter, and the next growth wave is moving into exactly the vehicle categories that shape industrial employment capital spending and supplier power. If US automakers answer that shift with expensive transitional architectures, fragmented supplier chains, and software stacks that lag, then the pressure will not remain abstract. It will land on assembly footprints, parts sourcing, battery plant economics, and the bargaining power of union labor in the next phase of electrification. And that brings us to the geopolitical endgame. Neta's own global cooperation page says it has already set up overseas eco-smart factories in Thailand, Malaysia, and Indonesia alongside its domestic base. That matters because it shows how a company in this ecosystem can respond when one market tries to shut the door. It localizes, it reroutes, it scales around the blockade. So the real question for the United States is no longer whether tariffs can keep one foreign SUV out. The real question is whether America can build an industrial response strong enough to compete when electric-first vehicles, LFP economics, and software-defined cabins stop being imported curiosities and start becoming the default expectation of the global market. What happens next will depend on whether the United States uses this warning to rebuild capability or wastes it trying to defend a cost structure and supplier logic that the rest of the industry is already moving beyond. The Neta L is not the final verdict on the future of the automobile. It is something more dangerous than that. It is evidence. Evidence that the center of gravity in this industry is shifting away from the old prestige hierarchy and toward whoever can combine battery supply, software integration cost, discipline, and scalable manufacturing into one coherent machine. China still holds an overwhelming share of lithium-ion battery supply chain capacity, while the United States has already responded with steep Section 301 tariffs on Chinese EVs and EV batteries. Those are not the signs of a stable order. They are the signs of a system under pressure. And that is the real warning for America. If companies inside this ecosystem can route around barriers by building factories in places like Thailand, Malaysia, and Indonesia, then the contest will not be decided by nostalgia slogans or protective rhetoric. It will be decided by who rebuilds capability faster. The old automotive age was built on the assumption that combustion engineering and brand heritage would be enough to defend the throne. Vehicles like the Neta L are exposing how fragile that assumption has become. This is not the end of Detroit, but it is the end of any illusion that Detroit can remain Detroit without changing.